Hi everybody, Chris AMS, hope you're all well. We thought I'd show you a vehicle that we're working on this afternoon. It's a Vauxhall Zafira 1700 diesel. Customers complaining that the vehicle lacks power and also the engine management light is on. We've taken the vehicle out and we've confirmed the fault by doing a test drive on it. So now we've got the vehicle in on the bay and we've carried out a cheeky code scan on it just to see what we've got. We've done a full code scan on the vehicle. So as you can see, the main one that we're looking at the moment in the engine system is boost pressure, low pressure. We have some fault codes in the ABS system. This is something that we're going to have a look at in a bit, and you might even see this on a subsequent video. We might have a look at this one for a different video, but we're going to concentrate on this video on the engine management fault. So next step is to bring up some live data on the screen, so stick with us and we'll see if we can diagnose this car. Right, so we've got the vehicle in, it's on the ramp, we're into live data on our scan tool. So on the left here you can see the boost pressure command is 98 kilopascals, which is atmospheric pressure practically, and we've got 100 kilopascals there, which is atmospheric pressure. Now this test is good with the engine switched off because it allows us to check that pressure as a reference against atmospheric, and it is reading atmospheric pressures, which gives us an indication that our sensor is reading correctly, although we're not going to take that for granted just yet. But so far so good, it's looking half right. So what we're going to do now is I'm going to start the vehicle up. I'm going to give it a foot full of throttle, get the turbo to cut in, and we're going to look at our boost pressure and we're going to see what happens to our boost pressure when we give it full throttle. So bear with me. That's running. Now we're going to give that full throttle. Right, okay, so let's go back a bit. Let's in a second. So that went down to, so we can see there, if we look at the one on the left, this is a commanded thing, and that's gone up to 196 kilopascals, so nearly 2 bar of pressure. And our actual pressure reading we got there is actually gone down, it's not gone up. So that's below atmospheric pressure. So what we can see inside that is actually the intake system or the boost pressure has seen a slight vacuum. So it appears at the moment that there's no boost occurring. So we've had a cursory look around at the boost pressure hoses and the intercooler, they're all intact. I think our next step is to have a look at the turbo itself and the wastegate system to see whether that is operating correctly. So yeah, next step is we're going to get it up in the air, we're going to have a look at the turbo. Right, so we're under the vehicle and we want to take a look at the turbo system on it. Now the first test we're going to do is on the vehicle's wastegate. That allows excess boost pressure to escape. Now if the vacuum system or the wastegate itself is seized, then the vehicle will never build up sufficient boost pressure in order to drive quick enough. Now if you remember from our fault codes, it was boost pressure low as a circuit. So it gives us a possible course that the turbo wastegate is stuck in an open position. So what we've got is I've got a vac tester out. So the wastegate is on the bottom here. It's a vacuum operated wastegate. So if we apply a vacuum to the wastegate, we should see the rod move. So I'm going to start creating a vacuum there. And you should see that move. Great stuff. And if you have a look at the gauge here, we can see that that's pulling half a bar of vacuum quite easily, and more importantly, it's holding the vacuum as well. That indicates that the wastegate diaphragm has no leaks in it, and it's capable of holding pressure, and it's moving the rod. So from this point, we can safely say that the turbo's okay. We're going to move on to our next test. Right, so our next portion of testing is we've gone back to the solenoid valve on the back of the engine bolted to the block. The solenoid valve links the vacuum pump on the back of the cylinder head down through an electronic opening and closing valve that then allows vacuum pressure to the turbo. So from here, we can check to make sure all the pipe work to the turbo is okay. So I'm going to pull a vacuum. So the vacuum solenoid is this bit here. It's difficult to see. You can just see that white bit there. Yep. And then we've pulled the pipe off and that goes to the turbo. So we're pulling the vacuum. And again, that's holding a nice vacuum. So everywhere from the solenoid valve to there is okay. Now, we could have just tested that first, but like I say, everything's a methodical process, so we like to be thorough. So yeah, so our next test will be to see if we are getting the correct amount of vacuum being supplied to that solenoid valve. So if there's not enough vacuum coming from the vacuum pump, or there's a leak between here and the vacuum pump, then that could be causing the wastegate not to operate correctly. So our next test will be to check the vacuum coming down to the solenoid valve from the vac pump on the back of the engine, and we'll see what we got. Cool. Right, so hopefully you can hear me. The engine's running. We are into the input side into that solenoid valve that comes down from the vacuum pump down and then feeds not only the turbo solenoid but also the swell flap solenoid as well. So in here we're using it as a gauge now, and you can see our vacuum is barely coming off of zero. That's, to me, that should be up, you know, half a bar easy kind of thing all the time. So to me that's showing that we have a vacuum supply problem. Now, it could be that we've got a split pipe, or it could be the vac pump itself. So what our next step in our testing is we're going to measure this again from the top of the vac pump where it comes out and supplies all the components, and we can see whether we've got an issue with the pipe or whether the pump. So yeah, let's have a look at the next step. Right, so just in between, we've checked the pipe work between the vac pump and the solenoid valve down there. That's all okay, no leaks. So if you look at the top of the engine here, on the back here, this is our vacuum pump. This large pipe here passes a vacuum to our brake servo over there and aids in braking. And then this little pipe here, that's the one that's feeding vacuum pressure to our solenoid valves and our turbo and stuff. So what we're going to do is we're going to pull this off, and we're going to put our vac tester on here, and we're going to measure what we've got coming out of there. So let me just pull that off. And I'm going to put that on there. So if we're looking at our vac gauge, we can see it's not very good. I don't like the look of that or any way, shape or form. It's fluctuating around quite a lot. That should be a lot nicer than that. It should be just solid, good vacuum all the time. Now what we can do next is we'll pull the servo pipe off, and we'll do a similar test. Let me just do that while you've got you on here. We'll pull this off of here. Let me get the tool out. So what we're going to do is I'm going to pull this pipe off of here, and we're going to measure as a comparative value what good vacuum looks like. They do make these clips a pain in the arse, so hopefully you can already hear that. If I put my finger over there. So if we measure that, that's what good vacuum looks like. Yeah, it's nice and solid. It's not going anywhere, okay? Now, the other test that we're going to do, I'm going to do in a second, is we're going to connect our vac pipe that controls our turbo and stuff directly in place of the servo pipe work, and see if we get our turbo back and we get reasonable boost pressure. Because if we do, then that's proof that this side of the vac pump isn't right. So yeah, let's set that one up and we'll show you that test. Cool. Right, so one of our last tests that we need to do is we have given our engine vac system a known good vacuum. So we've taken the vacuum supply off the back of the pump that supplies the servo, and we've bypassed it and got it to go into the engine side of the system. So what we're going to look at now is we can go back to our live data. Now you remember our boost pressure never really got over atmospheric pressure over 98 bar. at 98 kilopascals, sorry. So what we're going to do is we're going to give it a football now, and we're going to see if we got our boost pressure back. We're going to give it a rev. That's the screen. So now what we're seeing is we've actually got 160 kilopascals there, and we've got a nice big sweep up, and that's looking good to us. So I'm quite happy that we've got an issue with our vacuum pump. Now, one of the other things that we noticed, and hopefully it might show up on the thing, is there's actually positive pressure coming out of this pipe. Not a vacuum, actually positive pressure. Now it's chuffing away, it feels almost like it's exhaust gases. So what we're going to do, just to prove that, is we are going to do a intake system test. And we're going to smoke test it. So we're going to blow smoke up the intake, and then we'll see if we get anything coming out of here, because that would denote that there's a leak between the engine and the crankcase and the back of the vacuum pump, which would then, just as a last giggle, prove that the vac pump is faulty. So yeah, let's set that test up, and we'll see the cheeky final test. We've connected our smoke leak tester up. We use this for checking intake systems for leaks. So as you can see here, we've plumbed that into our intake system on the engine, and you'll see that it will have filled up the intake, the crankcase of the system. Now, hopefully, that will show up quite nicely. I don't know. Yeah, you can see it puffing away, coming out of that pipe there. Get right in on that. Don't worry about that one. But this smoke coming out of here is because there is a leak between the crankcase, so it's coming out the back of the pump and then allowing it to come out of the vacuum pipe. So it's actually creating positive pressure and negating the vacuum that's being applied or wants to be applied to the various components. So again, that was just a cheeky extra test. I was happy that we proved it up until that point. But again, all this stuff is about testing and not guessing. So from our fault code, which was boost pressure low, which could be this, that, or it could be a sensor, it could be a pipe, it could be this, that, the other. What we've done is, as opposed to loading up the parts can and throwing bits at it, we zeroed in our diagnosis, we've ruled things out, as you've seen, until we've come up with a definitive diagnostic answer, and we've not wasted loads of money replacing bits that we don't need. So we've proved the point. And this is the difference. This is what diagnostics is. It isn't just plugging a computer in and reading codes. It's doing proper testing, test, don't guess, to prove out what the issue is. Hope you liked the video. Check us out on social media. Give the YouTube video a like, and subscribe to our channel. Check us out on the Facebook page and our Instagram. Give us some likes and shares, because that always really helps us a lot. So we really appreciate your viewing. See you on the next video. Take care.